In this lecture, we are going to study the template method pattern. So we have seen many examples of the generalization of data. For example, this employee class is a generalization of this manager class. And in the abstract factory pattern, the abstract data class is a generalization of many concrete data classes. For example, the abstract auto parts factory is a generalization of Toyota auto parts factory and Ford auto parts factory. And the sortable vector is a generalization of student vector, sortable, and the integer vector. And data generalization gave us two key advantages. One is allow us to factor common code into the base class. For example, this manager class also has this first name, last name, hire date, and department, but we can put all these common things in the base class. And the second advantage that generalization gives us is polymorphism. Basically, the base class pointer can point to objects of any derived class. For example, in this bubble sort class, we have this sort decreasing algorithm and this sort increasing algorithm, and even another faster one, sort decreasing faster algorithm. And all these algorithms work with this sortable vector. This is the abstract class. Basically, any derived class that implement this sortable vector interface will be able to work with this sort decreasing algorithm and sort increasing algorithm and this sort decreasing faster algorithm. So when we use this sort decreasing or sort increasing or sort decreasing faster, we just gave a pointer to an object of a derived class, an object of the class that derives from this sortable vector. And in that class, of course, you must implement these three pure-virtual functions: get size, swap, and smaller. And if any derived class that does not implement all these pure-virtual functions, then that derived class will also be an abstract class. Then you cannot instantiate objects out of that. And here we have this student vector sorted by first name and student vector sorted by GPA, because they have two different implementations of this smaller, because this smaller is based on their first names and this smaller function is based on their GPAs. But they have the same get size and swap. So we factor this common code for this get size and swap into this student vector sortable class. And this student vector sortable, they inherit from sortable vector, and these two classes, student vector sorted by first name, student vector sorted by GPA, further inherit from this student vector sortable. So we know how to generalize data. Now the question is how to generalize algorithms. So the design pattern for that is called template method pattern. In this design pattern, we have a base class and we have multiple derived classes. In the base class, we have a template of an algorithm. We implement a template of an algorithm. And this algorithm has many versions. And in the derived class, in each derived class, we implement a specific version of the same algorithm. So the template algorithm basically consists of a sequence of steps. This template algorithm is the one that implements in a base class, has a sequence of steps. And some steps may be the same for different versions. For different versions, some steps are the same. Then in that case, then we implement these steps in the base class. And some steps are different for different versions. In that case, we define these steps as pure virtual functions. And in each derived class, we implement these steps, these pure virtual functions differently. So the concrete algorithm inherits basically in the derived class, we implement each concrete algorithm in which we implement these pure virtual functions. So by this generalization allow us to do software reuse. Basically, we can factor the common code into the base class. Basically, we factor the common code among different versions of the same algorithm into the base class. We basically implement this algorithm only once, and in each variant, we only implement the things that are different for different variants. And polymorphism is another advantage because the base class pointer can point to objects of any derived class. Basically, a base class template, the base class can point to any objects of this derived class, basically different versions of the algorithm. So this is the UML diagram for this template method pattern. So this is the base class. It has a template algorithm. In this template algorithm, it consists of, say, in this example, consists of 4 steps. Some steps are concrete. Basically, these step 1, step 2 are the same for different variants. Then we implement them in the base class. And some steps are different for different variants. Then we leave them as pure-virtual functions. So that's why this is italic. This is an abstract class, and these are pure-virtual functions, so they are italic. And in each different derived class, we implement a different version of this algorithm, and we basically just provide the implementations of these 2 pure-virtual functions. And in this, for example, in this derived class, it will inherit this template algorithm function. It will inherit this derived class inherits this, and also inherit concrete step 1 and concrete step 2. And these 2 implementations will override these 2 virtual functions. So if in the template algorithm that this derived class inherits, the 4 steps will have concrete implementations. So this template algorithm can run correctly in this concrete algorithm object. Same thing for concrete algorithm 2 and concrete algorithm 3. Each of these derived class inherits this template algorithm. And although template algorithm cannot run in the base class, well, base class is abstract, right? And it can run in the derived class because the derived class provides these implementations for these pure-virtual functions. So all the steps that this template algorithm need to run have concrete implementations in the derived classes. Then next, we are going to go through a few examples to explain this template method pattern. Let's first take a look at this funny example. Here we have several workers: firefighter, lumberjack, and postman, and the manager. And we have this daily routine algorithm, which is the same for all these different workers, because they all need to get up, eat breakfast, go to work, and then return to home and relax and sleep. So for different workers, their work functions are different, because this firefighter need to do this firefighting work, and lumberjack need to do the lumber work, and postman need to do the mail work, and manager need to do the managing work. So their work are different. But they all have this same 7 steps of the daily routine: get up, eat breakfast, go to work, and then return to home, relax, and sleep. So in this base class, this work function is a pure-virtual function. Each of these derived class provides a function for this work. And you also notice that in this manager class, this derived class, it also provides a function for this relax, which will override this the relax function in the worker. But that's maybe because this manager is a little bit richer, so they have a different way of relaxing than these workers. And these workers, they have similar income, so they relax in a similar way. So in the base class, we can provide a default implementation for this relax function. And for this manager, if you like, then you can override it. Here in these UML diagrams, you also notice this notation of a plus. So this plus is in front of a function. That means that this function is a public function. And we know we have protected functions also. So for protected function, you use this pound sign. And for private function, you use this negation. And for packaged, you use this tilde. We don't need to care about this package. And for private, typically in UML diagrams, you don't include private functions anyway. So most of the time you use this plus or this pound sign will be totally enough. All right, let's take a look at this second example. Here we have we are doing some data parsing work, and the input data, they have different types. We have input data may have maybe CBS files or maybe MySQL database files. And for this data parser, we have this parse data function. This is base class, and this is parse data function. In this is the algorithm, template algorithm. In this template algorithm, we have 3 steps: read data, process data, and write data. And you can see that for different input files, the read data function will be different, and process data function will be different. But the write data, after we get the data, probably the same thing. So then the write data, we implement them in the base class because they are the same for different derived classes. And for read data and the process data, because they are different for different derived classes and there's no default implementation, then we leave them as pure virtual functions. And again, so if they have default implementations, then you can leave them as non-pure virtual function. You can give the default implementation, and then in the derived class you can choose, you either override it if you have a special implementation, or you just use the default implementation. And for this application, of course, they are different because read CBS files and read SQL files are different, and process them will also be different. Now let's take a look at the third example. In this example, you are dealing with some documents. So this is, you have a basic document class. It has a file handler, and you have some functions like open file and read lines and so on. And then this is a basic document class, and then you have a derived class which deals with rich text document. Then you have this you have the additional attributes, say fonts, right? And then you have your own implementation of this open function. And also we have this document manager class. So in this document manager class, we have this template algorithm, which is called this OpenDoc. In this OpenDoc, you basically the algorithm is pretty simple. If I can open it, then if I cannot open, then I return, and if I can open it, then I just open this. Then I create the doc. So, and this document manager has 2 derived classes. One is for non-shared document, and another is for shared document. For shared document, then you need to have logs. Then for non-shared document and shared documents, their way of can open and create docs are different. For example, say can open. For non-shared document, you don't need to check logs. You don't need to deal with logs. And for shared documents, you need to have the attributes of additional attributes of logs. And when you test whether you can open a file, then you need to first try to obtain the log, and if you can get the log, then you can open. So you can see their implementations for can open are different. So in this document manager class, so you implement this algorithm, can open doc. This is the template algorithm, and it has 2 steps: can open and create doc, which are different for each derived class. Then you leave them as pure virtual functions, and in each derived class they provide a concrete implementation of these 2 pure virtual functions. Alright, now let's take a look at the 4th example. In this example, we are dealing with the sorting algorithms. So in the abstract factory pattern, you have seen the code of the bubble sort algorithm. And we have, in the bubble sort class, we have 2 algorithms. One is sort decreasing order, and one is sort in the increasing order. What obviously we can notice that these 2 algorithms are almost the same, right? So except this one line of code. Basically, you test whether the element is smaller than the you test whether the I minus 1th element is smaller than the ith element. And for sort decreasing, if the I minus 1th element is less than the ith element, then you are going to swap them, right? And for increasing, this will be totally opposite. So that's the only difference. There's only one line of difference, right? The rest of the code are exactly the same. Of course, we said that every time you copy paste a big chunk of code, that's an indication. Often is an indication of a bad design. So when you after you implement this start decreasing, when you implement this start increasing, of course you are going to copy this big chunk of code, and then you just replace this one line, and this is an indication of you can design better. So what we want to do is that we want to factor the common code into the base class. We want to implement this the common code only once, and then we want to implement this sort decreasing algorithm and sort increasing algorithm as different versions of the same algorithm. So of course, then we should use this template method pattern to refactor the code. How to do that? Okay, so here's the way to do it. In this, you have this base class bubble sort template, and here we have this sorting algorithm, this bubble sort algorithm. And in this bubble sort algorithm, you see that this bubble sort algorithm also works with the sortable vector. And because there's only this one line is different, then in each derived class we implement them differently. And here we want to make it common, right? We want to make this one line common. So how to do that? We basically say need swap. We basically want to know that whether the I minus 1 element and the ith element in the sortable vector, they need to be swapped or not. And in the sort decreasing, when you sort them in the decreasing order, then you will, if you call the smaller, you basically call this the smaller function on this sortable vector, give I and j, right? So so if the I minus 1 element is less than the ith element, then the sort decreasing will swap them, right? So in this template algorithm, we have this step need swap. We have this step need swap. The rest we code them in this sort algorithm. And this step is different for different derived classes. We have two derived classes. One is sort decreasing order, and another is bubble sort in the increasing order. And in these two derived classes, their implementation of need swap are totally different. So are different basically. One is check call this ing, give ing to this sv smaller function, and if the ith element is less than the jth element, then this one return true, and this one just return the negative of that. So these two are just the opposite. In this way, so you can see that we implement this bubble sort algorithm only once, and the code that's different, we implement them in the each derived class, and simply by this one line of code. So in the future, you can see the advantage of doing this. So in the future, if you want to optimize this bubble sort algorithm, you only need to optimize here. You only need to modify this sort algorithm here. You don't need to modify in two places. Otherwise, you have two copies of the same code. Then if you want to modify, you have one way to optimize it. Then you need to change two places. Here you only need to change one place. Alright, so this is the improved UML diagram for this bubble sort template and bubble sort algorithm when we deal with the sorting student records. So this bubble sort template, we have this sort and need swap, and bubble sort increasing implement need swap in the increasing order, and this bubble sort decreasing implement need swap in the decreasing order. Now let's compare data generalization and algorithm generalization. So for data generalization, the derived classes inherit data and methods from the base class and do something extra that we have already seen that. And the derived class, the derived classes do not need to provide anything to the base class, and the base class does not need to depend on the derived class to do anything. And for algorithm generalization in the template method pattern, it's different. So the derived class inherits algorithms from the base class, and derived class provides function implementations for the base class to run. Basically, implement the purity functions. Basically, these purity functions are the steps that need to implement the algorithm in the base class, and the base class depends on the algorithm class to run. The base class depends on the derived class to run. Here are some implementation issues and reading assignment. So the primitive operations, basically the steps that template method calls sometimes are declared as protected to ensure that they are only called by the template method sometimes. And the primitive operations that must be overridden, you should declare them as pure virtual functions. And the template method itself should not be overridden. Therefore, you should make the template method a non-virtual member functions. Naming conventions. So you can identify the operations that should be overridden by adding a prefix to their names. For example, in the Mac app framework for Macintosh applications, the prefix that the template method name uses is to add this prefix do. For example, you have a step, create document, you add do, means that for each derived class you do need to implement this. And this do read means that this will do something. That's what is the thing? It's just that's the reading work. That's the reading step, and so on. Okay, so for the reading assignment, you need to read the template method in the chapter in the textbook.